Hello students, I am Tirthesh, Department of BCA, Kaveri Degree College, Gonikoppal. For this semester, I am going to handle computer graphics and welcome to for fourth semester. Hope all are safe. So today, let us learn in this video what is a computer graphics, why a graphics has been required for us, and what are the things, substitutable things what we are going to learn in our computer graphics system. Before that, what is a computer graphics? Graphics means a movable thing. We can speak as a movable things, or what pictures you see that becomes a graphics. And here everything requires some the unit where we are going to focus it on, or where we are going to show the things how a graphics must to be postponed, or it should be required in a system. What is this computer graphics? Let us learn one by one. Before we are going to proceed with this, we're going to see some topics what we are going to cover in the chapter 1. The first, the introduction on graphics. What is the graphic system? Why a graphic system is required, and different kinds of things we are going to learn in this. The second concept is the images and the object. Never remember that what is the images and object, we have difference in that also. What is, we can't say everything what we see it is an image, or everything we see it is an object. Where you know what is an object, it's a real world entity. But how a object is been related in a computer graphics, you doesn't know thing. Hopefully we are going to learn that things also. Next, a representation of image. How we are going to image, we are going to represent that image, in what format we are going to represent. As we see, a representation, or we keep our image in the JPEG formats or PNG, whatever the things is, so that you are going to learn in that. The next concept is raster and vector based image. What is a raster based image, a vector based image, which is best in both? We are going to learn that. The next, the applications of computer graphics. Nowadays graphics has been used very widely. So have wherever we see, whatever we do and do different kinds of things, we see a graphics over there. So the graphics has been utilized manywhere in different quantities and different entities, or in different enthusiastic of systems. Next, we are going to see the display devices like LCD, LED, CRTA, and different kinds of things we are going to learn in that. Next, a coordinate system, how we are going to actually represent our graphics in our programs, or what is this the things, what small individualities we are going to learn in that. Next is graphic libraries in C programming. We are going to learn these things in this chapter 1. So these are your topics what we are going to cover in this chapter 1. So one by one, let us go to the topics. First, the introduction to a graphics. So what is this graphics actually mean as? We see a computer graphics, it is a field of computer science that is concerned with digitally synthesizing and manipulating a visual content. What they say there, it is a computer science field. We say it is like a science itself, where we are here when we speak on a science and all, we relate a object, or we relate some things, and we are going to learn on that. The same way here, we are not going to relate on a content like when we speak what we say about a textual or a different kind of thing, we are not going to deal on that. We are going to deal on a visual content like images, GIF, or any kinds of things. What is that we are going to see here? A computer graphics are a picture or a film created by a computer. As I said first itself, the moving images created by a system, that's called as a graphics. Like a game, a computer game, if a object need to be moved, you need some lines, you need to be have some forwarded things, right? So that things are being seen over here. So here a computer graphics are the picture and a film. What is this? Picture and a film. So previously in your before a digital era used to come, you need to see a film, a tape. What happens there? The things used to move on, the picture has to be captured inside that tape. Even that is a graphics itself. Now the things are being extraordinated, or it is been advanced. So here the usually the term computer graphics is generates, or you can say a graphics is a computer generated image or data created to specialize the graphical with the help of graphical hardware or a software. So what is the computer graphics? Now you understood, hopefully. A graphics, it is a picture, like a picture in the sense it is like a image content, or we can say not that a image content, we say a graphics. Even with the help, when you can see your even handmade graphics we can do by rotating our pages. Hopefully you have seen those things, I think. So that things becomes a graphics here. Here what they say here, a computer graphics are a picture and a film created by a computer. So how you are going to create a computer, like how you are going to provide a solution with the, for example, you have a problem, what do you do, you like in a C++ you have a the problem has been given. To solve, you use a turbo C++ platform with the help of hardware and software. The same way the graphics has been created or generated with the image data, that is with the help of image data created with the help of hardware and software. Here this technology is sometimes called as science and technology of creating, storing, displaying, manipulating images and object. So creating an image, like if I say I need to create some games, means I need to have some objects, right, to move from further and forward. So this technology, it is kind of a science. Like a science, it creates some things, right? So for a COVID-19, we required a vaccine. So what happened, with the help of a science, with the help of doctors or a scientist who introduced a medicine like vaccines or Covishield, means it's a science. What it did, it helps us to create something. So always the science helps us to create, unless it will not delete the things. So same way, this technology helps you to create something and helps you to store data and display the things, manipulating the images and objects, so on. So here, the vast and recent development of areas of a computer science, the computer graphics has made the digital images drawings have been easily modified without any paperwork. So what happened here, the computer graphics has been made a drastic change with the help in a latest era. So before, each and everything we used to do some in a handmade, right? Your photography, the previously they used to go to a dark room, they should take up the data and come up. But now what happened, with the help of computer graphics, you get all these scanned images with the papers. It is very easy to modify the images, unlike using the paperwork, wasting the paperwork, right? Scanning the things, animated things, you can speak on the things also, right? So here, in when we speak on academic terms, what is this computer graphics, why graphics, what does it mainly focus on? Here, a computer graphics mainly focuses on a mathematical and computation, how an image must be created or how an image must be processed. We are going to see with the help of computer graphics. Here, mainly, this computer graphics deals where the things where a computer graphics is going to be deal in a system. First, it helps us to in representation and manipulation. So either when I say about representation, you can, how images are being represented either in a two-dimensional format or a three-dimensional format. So this two-dimensional, three-dimensional manipulation, in the sense movement, some things must be there, right? That is what helps. The graphics mainly deals with representation and manipulation. Second is creation and manipulation. So creating a new things also a graphics is required. Next, production of images, for production data or images to be produced or to be synthesized or to be utilized in a system, for that also a graphics is required. Last, the study of digitally synthesizing and manipulating a visual content. For what? For making the things, like for example, if an image is already present, what you need to do something different in that, or you need to work on something different on those things. So what do, you do different synthesis, or you do some kinds of data enthusiast, like what you say here is a graphic. Simple example, if I need to say, for digitally synthesizing and manipulating, like you take out the image, the noise, the background noise, you're going to cancel that with the help of some softwares or do something and make that image look beautiful. and marvelous. That becomes a computer graphics here. It is also a subfield of a computer science where the study is mainly deals with the visual contents. It is a subfield of a computer science here. The data or a study of a day computers or graphics is mainly deals with the visual contents of a system. So this is about your introduction to a graphical system. The next is images and an object. What is an image? The image is a representation of an element in on a computer. The image, what we say, is a representation. We may also say that it is a picture, means non-movable picture. Like we have pictures, like nowadays we can see any kinds of things. They map things, map a data, means what they do with the 3D mode itself, right? Before building a vehicle like a Lamborghini does, right? So what they do, they prepare a 3D model, right? This 3D model is not an image. Understand properly. What we speak on a 3D model, that 3D model may not become an image. Okay, that becomes a data or an entity of that things. Image, in the sense, it is a small minute particle. So what is this? You can see a image may be an actual picture display where page is been stored in a video memory. So what is this? Like a jpeg, means it is a stagnant image, or it is a never moving image, right? GIF, what happens there, you have an action. That is not an image, right? GIF, graphical unit image, GIF, right? That's what we say. Means here they say the image may be an actual picture. It is a small, like it's content of a picture, like a scenery. You take a photo, that becomes an image. That means that is what an image, where pages are being stored in a video memory. Next, here the image is a visual representation other than a text. We are not speaking on a text here now, right? Now we are going to only speak on images. What are the images? What data we are going to take? How we are going to store an image? So here, what is an image here? An image, it's a picture, or it is a pixel. Collection of pixel makes an image. That becomes image. And here we can say that image is in a 2D data, 2D array, two-dimensional, which has number of rows and columns, and rows and columns. So they can say here array of data with the values, and each element of an array is been related to different colors. So you guys know that how many different kinds of colors are there. We have 0 to 255 different kinds of colors, multiple different kinds of colors. We are going to take interrelate them and utilize that data into a entities or enthusing things. That becomes an two-dimensional array or 2D data. Okay, so the what is that images now? I hope properly understand. It is what? It is a representation of an object or an element in a computer, like just a representation. So you say we have a car. How you are going to represent that car? With the help of an image, correct? Or I have some kinds of drawing. I need to say that you need to prepare me this kind of software. What I do, I never build and give a thing. What I do, I just draw a things. Means I picturize the thing. Now, not that I am going to work on that thing. That's what an image is. Here, what they say here, the image is an actual picture which is being stored in a video memory. Here, text, there is difference between a text memory and a video memory. Say for the example, a video memory means just in a big memories is with varies. It is a differentiated based on a size, not on a things. Okay, based on a size but not on a things. So the images are visual representation other than a text. Visual means what I can see. Even you can say, sir, you say that visual representation means the text also I can see, but what is the difference there? But text, it is in written format. This is a video, or it is a watchable format. You can say as a watchable format. Here, all the images are being stored in a two-dimensional array, which has rows and it has a columns to be specified. Okay, that is the what a image is. But what is an object then? An object, it is a real world entity which is defined in a 3D word coordinates. 3D word coordinates in the sense what? If you turn around each and everywhere, you can see the 3D resolutions. Means that you have an object, you turn that side, this side, you can see each and every entities. What is that? That is what a object is. Here we can also speak as a GIF image, a movable image. Also we can say the better flexible for generalizing the cost of complexity for a from this object manipulation. We can get a flexible solution. Means obviously you can get a solution with the help of an image also, but you can't get to the details inside that. So with this object manipulation, what you get a flexibility where you can understand the things properly, and you can memorize, or you can what you can say, like you can do the things many widely or varietily, whichever the things you require to do. That is what object is. Here when we observe this, what do you feel here? Here you can say that the image is being written or does the two-dimensional work. Image is being done with the help of two-dimensional work, and the object which works on a thing, it is been described with the help of three-dimensional data. And they also say both the image and objects are used to transformation of for generating a video display, even with the help of GIF, or with the help of 3D contents, or with the help of 2D contents, we can combine to do one movie also. Can do any kinds of things. The transformation may be directly performed on an object coordinate or a image coordinate. Anywhere you can do the things, but the difference we have that when we speak on an image, it is done in a two-dimensional format. Means 2D arrays, we used to do the things in the help of 2D arrays. When we speak on this objects, it is done with the help of 3D real world entities. We always, what we do here is we always relate to a real instances, like a house. To build a house, what do, you give a blueprint. Your blueprint is been given in a sketch or in an image format also, or by building a 3D model also. You can see nowadays what happens everywhere, like in a showroom also. Nowadays, due to the COVID pandemic, you can go to a showroom to check out your car, a newly bought up car. What they do, they give you 3D resolution, 360-degree of your car with the small image itself. That also becomes three-dimensional image, where there is a movement in that image data. This is about the images and the object. Hope you understood. The next concept is representation of an image. Before I going to say about representation of image, what is this? Because I'm going to speak on a memory, how a image is being represented in a memory. So here, the computer graphics is all about a data model handling. How you're going to handle the image entities, how well you're going to store an image, and what are the different contents you're going to use. That becomes a image representation. So here, whenever we say a representation is a shape and image that makes a new creation, or synthesizing synthetic construction of an existing one. Okay, so what is this? The representation of a shape. Here the representation of shape means it may be a new creation, or taking a older one, removing the things which is not required, synthesizing or exchanging the things and constructing a new one. That may be also possible. Here the main goal of this is reasonable, and to have or to generate the reasonable and informative image by removing all the noises from that data. And next, the computer graphics, it's a picture, it's a collection of a pictorial elements or a picture elements called as pixels. So as you know about this picture, how a picture has been created. A picture has been created with a collection of minute particles called as pixels. What is the pixels means? A small square inside a picture. How you're going to see that when you zoom an image in 12x or a 15x or some different kinds of things, at the time what happens here is the image is been formed with the minute squares inside that. That becomes a picture. So computer graphics, it's a picture. It's a In a computer graphics, the picture is a collection of discrete picture elements called as pixels. Discrete picture elements called as pixels. Here, what happens? The process of determining an appropriate pixel representation for a picture or an object is called as rasterization. So, what happens here is, as I said, a collection of pixels makes a picture. So, how many resolution, what quantity or what amount of picture you require to be shown? Okay, like a image, to form a image, I say that I'm going to create a new like I'm going to create a house with the help of paint, but I need to say what is the actual size of that image. That actual size or actual it says the actual representation, that what pixel it should be represented, either 35 cross 45 or resolution. Like we can speak on a resolution also. That resolution matter, that resolution term, we call them as a rasterization, means the process of determining an appropriate pixel of representing a picture. Appropriate pixel for representing a picture means what? Like a resolution means the size. Also I can speak on that. So the process of determining the appropriate pixel for representing a picture or object is called as rasterization. Next, this continuous rasterization, or what do you say, the process of representing continuous picture as graphical object is called as screen conversion. So what I do, 100 number of pictures I combine together, I provide some sounds, I make that to play. What happens there, the movement of picture you are going to observe that is called as screen conversion. So the process of representing continuous picture as a graphical object. As I said, our object is a real world entity. What happens there? You can, the movement of a things also we can say that is a graphics, but it should be a computer made. Okay, so here I say the process of representing a picture as a graphical object is called as screen conversion. So the more mainly how a graphic is being studied, or what is the use of this graphics. If we see, the graphics is mainly deals with storing and manipulating the digital image. Mainly why a graphics is been required, the graphics came into the picture for digital solutions. Okay, so how well you are going to store a data, or how well you are going to accept the entities of a data, you are going to see that that becomes a graphics. So as we know here, the mainly this graphics runs with the help of mathematical equation. Why a mathematical equation has been required? So why can't we do the things directly? Means if you ask me, always when we speak on a pixel or a picture, we can't directly use them in a proper mechanism or mannerism. So what happens there? There may be some minute mistakes how manually if you do, but the mathematical equation, what does it do in here? This gives an appropriate value. Hence, there will be no noise in your picture or in your graphics. So here, what happens here is, in a mathematical equation, this graphics is always represented with the help of mathematical equations itself. You're going to learn that in your further coming chapters. So what happens here, in a mathematical equation, the signal are represented as a function of two independent values as x and y. So take a graph. If you divide that graph into four parts, you know x bar. Okay, what you say, positive things is called x, negative things it becomes x bar. Positive things here becomes y, negative things becomes y bar. Means horizontal things are comes under the x coordinate, vertical things comes under a y coordinate. Okay, so that's what we say here. The things, how a mathematical function is been utilized. So if I say there are two values, if I speak on the things here, there are two values which is called as a monochrome digital image. We call that mono means single, right? So one image to be formed, it has two coordinates like x and y. Okay, so for that reason, a image is been represented in a 2D, two-dimensional means rows and columns. Okay, so to have, for example, when I speak, the brightness function has has a values. So when you need to create a data or when you need to run a image in a brighter format, or you need to work on a brightness, so what happens there, you work in an entity, in a mannerism. So here what happens here is these two x coordinate and y coordinates provides you the grayscale value. Like when you run a graph in a max, where you are going to plot a graph, means what you do, x of 0 comma 0 means where x1 y1 means you're going to point at that in a 0 comma 1 means you're going to put a star mark over there. Then what you do, you move next, put a star mark, after that you're going to join the lines, right? The same way here also. Okay, so here 0, what we always pick, a 0 becomes a least value over there. 0 becomes the least value, and uh, 255 becomes the most value. So always we have the bit numbers from 0 to 255 means 256 is the monochrome data. So when we say a binomial means it becomes 512. Okay, so this is what a representation says. Here each element of an array, inside this array, each element of the array is called as pixel, means picture element, pel. Okay, so the element here, all f of 0 comma 0, 0 comma 1, whatever the things are, whatever I'm going to show in the matrix, that becomes a pel means picture element. Okay, so here mainly the image dimensions comes in under 256. 256 into 256 means 0 to 255, as I showed, m minus 1 and n minus 1, 0 to 255, and 512 into 512 means that becomes a much extraordinary images. So this is how a image is been represented, always in a two dimension. How, why I said about two dimension means this is how. Here always this, remember one thing, each and every point in this picture contains the color value. So x and y always becomes a grayscale. And whenever I am going to represent my image, I am going to show that image with the help of grid format. This is about your representation of an images. The next part is raster and vector based graphics. Before that, let us learn what is this raster. The raster is always called, also called as bit image, bitmap. It's also called as bit image or a bitmap image. So what is this bit image or a bitmap image actually? So here this mainly focuses on a pixel based, means I'm going to show how an image is also. Okay, this is mainly based on a pixel, how a pixel is being generated in a system, or what kinds of pixels, how, when how a image is being utilized. Okay, here what is a pixel then? A pixel is a small particle of a picture. So here in a raster based image, each pixel has been assigned with its own color. So when you can see that when you go to your painter, when you select a more color, you have an option of a small arrow mark over there. So when you move from top to bottom, the color changes from dark to light. Means what happens there? Each and every small minute particle has a square box. It has its own pixel wherever it is going to represent. The information stored in a bitmap image is regardlessly about a pixel location and a color frames forms in that image. What are the information is been stored in a raster image then? The raster image has a pixel location and the color frame. Pixel location means the address of that location, of which color it is going to be holding, and the frame where it is going to be worked. And here the bitmap image are being edited at a pixel level, allows us to color allows us to color one pixel at a time. it helps us to be change only one pixel. So based on that itself, I need to move the other. I can't say I can directly complete select and run the image. Here, what is this raster image based image then? Whatever things you do with the help of Adobe Photoshop, that becomes a raster image. Whatever things you do in Adobe Photoshop, that becomes a raster image. The images you are usually created and edited on a photo application or paint program such as Adobe Photoshop or different kinds of things, whatever you are going to use, that becomes a pixel image. Here, the images are being represented in the form of grid or in an array format or with the help of array format. Any kinds of things what you do, like in a two-dimensional itself, whatever you do, the things that will be in a two-dimensional format itself, that becomes a raster based image. And the size of the image is based on the image resolution. Now think, first itself I can't fix that, I need only this kinds of size. When you completely finish creation of that image itself, we can say that the images is only till this end or only to that mannerism or that mechanism. So what is this? The size of an image is based on the image resolution. Means you can't say that what image you are going to say create when you add some entities to that images, or when you do some different kinds of things, what happens, the size increases obviously, right? So now when I say I need to do only 5 minutes video, if I include more number of contents to that, what happens, the video will be enlarged. So that is what we say, means the size of a image is based on a image resolution. Okay, next, it is realistic images involves in a complex color variation. It is the realistic images, but obviously it is a realistic image, but as I said, it only allows one pixel to change one pixel at a time. Means what happens? It takes obviously if a complex image has been given, then it takes lots of time. So it is a photo realistic images. It involves the complex color variation. What kinds of images are raster images? Means it is a photo stick, like what digital photos you take, like for passport size photos, that things becomes a raster images. Clear? Next, based on that, what is this vector based image then? The image which has been created with the help of mathematical formulas. The image which has been created with the help of mathematical formulas is called as vector based images. Like to create a line, we have some commands called as line. To create a shape rectangle, we have a command called as rectangle. Or to say circle, we have a command called as circle. Means what happens there, uh, for that line, if we give particular values to that, it matches there and helps us to draw some lines. That becomes a vector based image. Okay, here they contain the instructions about the location of the component to be created, except the element and embedded in a bitmap within a vector graphics. Means what is this? It has the content from A to Z, like not like a bitmap. For a pixel, it has a solution. If you select every kinds of things, then what happens there? You can easily create a vector image. Understood? So what they say here means they they are the persons, or they are mainly has some instruction about their located, where they are located, each component to create the expected element, and even helps us to embed a bitmap graphics in this in vector based image. So what they say here, as you know, the previously as I said, it has the pixel location and a color frame, but here the where the it takes a information where a component is actually located, from which x axis to which y axis. Okay, and even that how a component has been created also it is going to show us. Next, the object are independent to one another. It is not that you should, if you draw a line, you should only draw a line. Like only it doesn't have only single lines. You can keep different shapes, like you can create a circle or you can create a rectangle. What it says means circle, line, and different kinds of things are objects, but each and every object runs its own fashion. So what does it say here is the objects are independent to one another, not that it is not dependent thing. Okay, next, this image have smooth edges and creates easy to create curve shapes. Okay, so here what does it say here? It has a smooth images and very easy to do the different kinds of works. Means the lines what we are going to draw, it will be accurate, not it's very like it is very disgusting. Like when you do zoom, if you take a picture and zoom that, in a vector based image what happens, you find a boxes. Okay, but in a raster based image you find a boxes, but not in a vector based images. Okay, next, these images are very good for precious illustration, and it is very easy to scalable due to it uses a mathematical formula. Like for example, you have already used a paint application. So when you use a paint application and when you have to remove a line, if you click on eraser and if you remove, what happens, sometimes there may be a chance to remove every pixel also, right? But here it is not like that. As I said, it uses a mathematical formula, means for everything it has its own commands. So by changing the value you can do different kinds of operations. Okay, this is what image is. Here the images are very smooth in any size. But what is the main thing you need to understand over here? The vector based images are very difficult to be created than a raster based image. Why? Because the pixels means it is obviously we all know how much what is the things and all, but vector based image never gets any ideas of that, whatever you require to do the things and all. So let us see how a raster based image is. So I just showed you have your image over here. You have a robot and have different individual colors. So let me pick a single color and I enlarge that in a 12x pixels. Okay, 12x means I enlarge them. I zoom that, completely zoom into 12x. So what happens there? Each and image, the image is what you see in your in this with the help of a robot, blue color image, right? Let me take any color like blue color itself. Okay, here it has a small dot, means a blue color. When you zoom enlarge that, here what you feel that that has a box kinds of things, small variant. That small boxes itself, it is a pixel. That is how a raster based image is being utilized. But a vector based image, you can see if how much whatever the zooming you do, the image will be clean and tidy. That is what a vector based image is. Hope you understood about a raster based image and vector based image properly, right? I think you understood properly. So this is what for this session. I'm going to continue this next also. Thank you.